Suppose we want to find the area of the region enclosed by the graph of the equation r equals 4 cosine of 2 theta. So earlier in this section, in the notes, I've given you this formula. Area equals 1/2 integral from alpha to beta of f of theta squared d theta. So this gives you the area of the region enclosed by the graph of r equals f of theta between the rays corresponding to theta equals alpha and theta equals beta. The thing to be careful of when you're using this formula is we cannot have the sign of our radius change within our interval of integration. So that's a catch to this area formula that we use with polar coordinates. So when we set up our integral that's going to give us area, we need to be careful of that. What we can do, though, a lot of these polar curves are symmetric. They all have a certain amount of symmetry, or most of them have some symmetry to them. This graph, for example, this is a 4-leaf rose. We've got 4 petals that all have the same area. So we could find the area of one petal and then just multiply by 4 to get the total area. Okay, but like I said, you have to be very careful how you set up these limits of integration, alpha to beta. So I want to think about the graph for a minute. So imagine we were drawing this graph by hand, and we were doing a little chart where we plug in a certain value of theta, and then we generate a radius using this equation, 4 cosine of 2 theta. So starting with theta equals 0. Well, if theta equals 0, then r is 4 times cosine of 0, which is 1, so we get a radius of 4. That's going to correspond to this point right here. Now, as theta, let me draw a unit circle over here. As theta increases from 0 towards pi over 2, the value of cosine, so that's the x-coordinate, is decreasing towards 0. And it's 0 by the time we get to pi over 2. If I plug in pi over 2 here, well, let's be careful. Actually, if we plug in pi over 2, we have cosine of 2 times pi over 2. So this is 4 times cosine of pi when you multiply by 2. So that's actually -4. See, this is the sort of thing we need to be careful of. Let me back up. What about pi over 4 radians? At pi over 4 radians, r is equal to 4 cosine of 2 times pi over 4. So that's cosine of pi over 2, which is 0. So actually, by the time we get to pi over 4 radians, which actually kind of makes sense, so pi over 4 radians, think of this ray right here, the value of r has decreased down to 0. So we've sketched this section of the graph as r goes from 0 to pi over 4. Now we've hit where r is 0, so it may possibly turn, well, and it will, right? Because we've seen that because we plugged in pi over 2. Between pi over 4 and pi over 2, when you multiply by 2, we're actually between pi over 2 and pi. So in terms of the unit circle, you're over here, you've got a negative value of r. Okay, but let's take this section of the graph that I just traced here. So again, as theta goes from 0 to pi over 4, that's going to generate this part of the curve. And so if we integrate from 0 to pi over 4, that's going to give us the area enclosed by the graph between those rays. That'll give us half of one of these leaves. Again, this graph is symmetric, so if you multiply by 2, you get one entire leaf. And then multiply by 4, you get the entire graph. So if we take the area of this region and multiply by 8, that'll give us the total area. So when you start these problems, you should find the values for which r is 0. That's when you're finding limits of integration. Let me give you this advice here. A good place to start is set your expression for r equal to 0. The reason that's a good place to start, so that's going to give you the value of theta whenever the graph comes in back into the origin. So that's going to give you the thetas that correspond to these rays here, which are the rays that frame each leaf of this graph. So if we did that with this equation, you'd have 0 equals 4 cosine of 2 theta. If we divide both sides of that equation by 4, we have 0 equals cosine of 2 theta. So now we think about some of the infinitely many solutions to that equation. So we think about when is the output of the cosine function equal to 0? And that's, again, if you think about the unit circle, that's at pi over 2 radians, 3 pi over 2 radians. So that's when this angle right here, 2 pi, equals pi over 2 radians. So theta equals pi over 4 when you divide both sides by 2. Or if this angle here, 2 theta, equals, so when else is cosine 0 at 3 pi over 2 radians. If you divide both sides by 2 there, you have theta equals 3 pi over 4, which is this ray here. And so the other ones you could probably find by inspection. 5 pi over 4, 7 pi over 4 would also be these tangent rays to the graph. Okay, so another way to do this might be to integrate from negative pi over 4 to pi over 4. That'll frame this leaf right here. And if you think about it, so if theta is between negative pi over 4 and pi over 4, then that's going to put this 2 times theta between negative pi over 2 and pi over 2. So that'll be an interval over which cosine's always positive. It's okay also to use an interval over which cosine's always negative. What you don't want to have is the value of our changing sign. So if you decided to use pi over 4 to 3 pi over 4 to frame one leaf of this graph, so if theta is going from pi over 4 to 3 pi over 4, that means that this 2 theta inside of our expression for r would go from pi over 2. So this would be 2 pi over 4, so that's where I'm getting pi over 2. And then 3 pi over 2. So pi over 2 to 3 pi over 2, that's where r is negative. And it's negative over that entire interval, so that would work. So you could set this up as an integral from negative pi over 4 to pi over 4. That would frame this leaf here. Or pi over 4 to 3 pi over 4 would frame this leaf here. Okay, and then you get the picture. So we could do half of this leaf times 8, or we can do the entire leaf times 4 to get total area. All right, that's a lot of information just about setting up. I think I'm going to stick with my original suggestion here, which is to integrate from 0 to pi over 4, and know that that's going to give me the area of half of one of these leaves, and then multiply by 8. Okay, but in general, when you're looking for limits of integration, set your expression for r equal to 0. And that'll help you find these rays that are tangent to the curve. Okay, so we've got a plan, now we need to execute it. So total area here will be 8 times the area of this half of a leaf, which is given by this formula. So 1/2 integral from 0 to pi over 4 of f of theta, which is this 4 cosine of 2 theta, all squared, d theta. Okay, so working that out, give myself as much room as I can. I would go ahead and multiply the 8 times 1/2, so that's 4, and then integral from 0 to pi over 4 of 4 squared, so that's 16, cosine squared 2 theta d theta. Okay, so move the 16 out, that's 64. Now we're integrating cosine squared. So now you have to think back to chapter 8. The way to integrate an even power of sine or cosine, you're stuck with only even powers. Because remember, sine cosine integrals, those are the ones where you look for the odd exponent, and you break one power away if you see an odd exponent. If you're stuck with only even powers, you have to use power reduction. So that means turn this cosine squared expression into 1/2 1 plus cosine of double that angle. Because power reduction is really double angle formula rebranded here for a specific purpose. So 1/2 1 plus cosine of 4 theta, d theta, integrating that. I think the graph here is going to have to go, but so keep in mind, the way we've set this up, it will give us total area. I just don't want to write everything down in the corner there. Okay, so I would bring the 1/2 out, so 64 times 1/2 will give me 32 for a coefficient. And then the integral from 0 to pi over 4 of 1 plus cosine of 4 theta. So now we can integrate that directly. Antiderivative of 1 with respect to theta is theta. Antiderivative of cosine of 4 theta is 1 over 4 sine of 4 theta. And this is evaluated from 0 to pi over 4. Remember, you can check this antiderivative by taking the derivative. This would be cosine of 4 theta times 4 would cancel this. So we get the cosine of 4 theta here. Okay, so now I can substitute the limits of integration. So pi over 4 plus 1/4 sine of 4 times pi over 4. So sine of pi. Let me get rid of this. Okay, and we'll come back to that in a minute. But minus 0 plus 1/4 sine of 4 times 0, so we know that's 0. Okay, so this is 32 times pi over 4. Sine of pi is 0. So this is 0. Sine of 0 is also 0. This is all 0 over here. So we end up with just 32 times pi over 4, which is equal to 8 pi. So 8 pi for the total area of that region.